What gets you excited? Like what's Jensen see in terms of how AI is going to impact all?
Well, we're all going to have a whole bunch of digital agents working with us. I love the idea that I'll have my own R2-D2, my own C3PO. People who are just growing up now, they're going to have their own personal R2 with them. All of us would have that.
Hi everyone, Mike Sievert here. Welcome to a special edition of Sidekicks Conversations. We recently had our T-Mobile Capital Markets Day event in San Francisco, and one of my special guests was Jensen Huang, the CEO of Nvidia. We talked about a collaboration we're kicking off, along with Nokia and Ericsson, to open an innovation center in Bellevue to bring to market a new network technology called AI RAN. Networks need to keep advancing in order to stay ahead of the big data demands of the world's mobile users. T-Mobile and Nvidia share a bold idea that building AI capabilities right into the network architecture will improve performance and capacity, and we're joining forces to prove it. This partnership has the potential to define what's next for customer experiences in the mobile industry and beyond. My conversation with Jensen was fascinating, so we decided to turn it into a Sidekicks episode. I hope you enjoy it.
Thanks for being here, man.
All right.
So, I've got to be the most uncarrier guest you've ever had.
Well, you've got your characteristic leather jacket today,
I like your jacket,
which is great. AI RAN, who cares?
Well, my gosh. Let's take a step back. First of all, in 2016, we introduced a brand new type of computer called DGX-1 and reinvented computing after 60 years. And the impact of DGX-1, which is now a well-known AI supercomputer, and it's powering AI all over the world, is changing the computer industry, revolutionizing how software is done and what software can do. And really what's happened is we created a new computer, a brand new type of computer that fused radio processing, insanely complex wireless algorithms. And most people need to understand the wireless communications. The spectrum is limited, the algorithms are complicated, the environments are diverse, dynamic. Electromagnetic radiation is not a simple physics, and yet you're trying to optimize the quality of service for everybody, manage the spectrum, manage energy efficiency.
Yeah, this stuff's harder than it looks.
Oh
right?
my gosh.
It's massive. We all take this for granted. We go around with these incredible computers in our hands, and by the millions, we connect it, to vast quantities of data being sent down at hundreds of megabits per second, no matter where we are. And in real time, the computing power to give each of us the signal we need, it gets harder and harder and harder the more we use. And so this is all about getting more and more performance from each unit of frequency.
And for the very first time, we're going to bring artificial intelligence to it.
So let's talk about that. So how does AI help with all this?
We're going to have to create a brand new type of computer, and the computer we created called ARC-1 fuses radio processing and artificial intelligence processing into one platform. And so as a result, we have the ability to do two things. We could apply all of the deep reinforcement learning algorithms that we use for robotics. We could teach these AI models how to optimize signal quality in hundreds of thousands of virtual cities that we showed you. Then when we finally put it out into the real city, then that real city becomes the 100,001 scenario. And so it's already learned how to optimize across so many different scenarios through domain randomization and simulation in these supercomputers. Now the next version, the next one in all these different cities and different environments, it would have been optimized before.
There's been a trend for a long time that we're moving in this industry towards a more open RAN architecture, towards software-defined RAN, trying to get all that sort of technology out of the radio and into the cloud for obvious financial benefits, efficiencies. But that has proved kind of elusive at scale around the world. How can accelerated computing of the kind that Nvidia produces with this new product make a difference and finally make some of these promises of virtualization of RAN technology into clouds a reality?
So the first challenge is, how do you move to a software-defined environment where Moore's law has really run its course. The CPU can't keep up with the workload of an ASIC. And so the answer, of course, is accelerated computing, using CUDA to do that. It took us 5 years to create the Aerial library, which allows us to use CUDA to accelerate 5G radio and prepare for 6G radio. The second thing is, of course, once we do that, then the computation stack can also support AI. Now we've fused signal processing and AI into one computing platform. Your radios are going to be extraordinary 5G radios and be prepared for 6G in the future, as well as an AI computing platform to deploy, to host, to run AI on it. And the AI could be used to, of course, improve the efficiency of the network itself, as well as, of course, host brand new AI services.
It's very clear to us and to most objective observers how far ahead Nvidia is in leading the accelerated computing transformation around the world. And for us, as we think about how that applies to our industry, it's going to completely change network architectures. And so, this 5G chapter that we're living in is several years old now. We're thinking about what's next, and we're thinking about how to get there in a highly cost-effective way. And that obviously means we've got to think about virtualizing the technology, put it in the cloud. And there have been barriers to that you just talked about. Traditional computing just can't keep up with the ASICs that have traditionally been deployed in non-virtualized, non-software-defined RAN environments. And so for us, our view is that if we can be co-authors of this transformation, we can have our engineers in there deep as not passengers on this train, but conductors working with the world's leader, like Nvidia, like Ericsson, like Nokia, to create the future. T-Mobile customers will benefit disproportionately. That's our belief. And we have that belief because that's exactly what unfolded in the 5G era.
Yep.
And that T-Mobile customers will get it sooner, and they'll get it better, and they'll get it more cost effectively. So we are very excited about inventing this future with you. There are 300 operators around the world. Why did you decide to work with T-Mobile?
Our first meeting, we connected the dots almost right away. And you saw the vision of the technology. You offered the massive might of T-Mobile and the incredible engineering team. Wolf and the engineering team leaned right into it. I think we all saw the same opportunity to reinvent telecommunications with the fundamental technologies that is reinventing one of the largest industries in the world, which is computing. And so this underlying technology will unquestionably revolutionize every industry. The fact that you jumped onto it, you personally jumped onto it, drove the conversation between our two companies, and then now our two engineering teams are working so intensely, closely together, launched this new innovation center, start deploying infrastructure so that we could develop the software, get the software ready, industrialized, optimized all over the world. It's going to be incredible.
You started to talk about a secondary benefit of all this that has us very excited.
Yep.
And I want to explain it. The idea of when we virtualize our RAN technology into the cloud, working with the world's leaders, what we will realize is that the same thing will be true of those workloads that's true today of mobile networks, which is the demands against each individual component are highly variable, leaving massive underutilized compute power at all times of the day and dispersed geographically.
That's right.
Sometimes it's taken up by the workload of the RAN, and sometimes it just sits there. And this creates an actual business opportunity for us.
Right.
We just talked with Sam Altman about the rapidly unfolding technologies in AI. And one of the things that AI requires is incredible latency, right? Fast response times, because AI is moving from its traditional formats of like text. I'll text you, you'll text back. No latency needed. But when we're responding in real time to videos and face intonations and working with avatars, that's going to need to be incredibly responsive. And the AI workloads of the future will need compute power in the network close to the customer. And the very compute power that we're going to build together to support this RAN capability could actually also compute secondary workloads for our customers.
It's exactly the same computing system now. We've fused radio computing with AI computing into one architecture, and we call it ARC-1. Now, one of the things that people don't realize is that the world's wireless networks are extremely over-provisioned, and you're over-provisioned because you have to deliver such extremely good quality of service when somebody needs it. But when somebody doesn't need it, that infrastructure is sitting there, and it could be reutilized. And so when we made it software-defined, made it accelerated, made it able to run AI processing, we now turn that entire network into excess capacity when you need it for excess opportunities. And so this is going to be a great new growth opportunity for the telecommunications industry.
What gets you excited? Like what's Jensen see in terms of how AI is going to impact all
Well,
of us?
we're all going to have a whole bunch of digital agents working with us. And I really love the idea that I will have a computer that is getting smarter and smarter with me as it works with me over time and understands me to help me get things done. I love the idea that I'll have my own R2-D2, my own C3PO. And my R2 will be following me. For many people who are just growing up now, they're going to have their own personal R2 with them for their lives. And that R2, of course, could be digital versions of it. It could be a work version of it. It could be a physical version of it. I mean, the idea that all of us would have that, whether you're a scientist or an engineer or a philosopher or just a person, we're going to have all of these amazing agents that help us, along with our lives.
The bottom line is this. Billions of people around the world are connecting at every second of every day to millions of cell phone towers. And that technology has the opportunity to understand the physical environment that they're operating in while they're in motion and while the world is in motion, and use advanced AI to predict exactly what signal will reach them best in order to give them the best possible experience at the lowest cost. That is, given the scale of this industry around the world, that is a massive opportunity for Nvidia, for Nokia, Ericsson, the other partners in the alliance, but also for T-Mobile as a co-author of all this, in working with our customers and potentially with our peers around the world. This is an exciting moment.
And Mike, for us, it's such a joy. It is very rare that we have a partnership where our technology and our know-how could be useful to you in how you run T-Mobile, but also in the technologies that enhances future products, but also expands the market opportunity together. And so this is such a great pleasure to be with you, and the partnership between our two engineering teams are just fantastic.
Well, Jensen, thanks for the partnership, and thanks for coming out to speak with our investors.
Thank you.
Yeah.
Thank you. Mike Sievert.
Good to see you. Jensen Huang, everybody.